How's it going, everyone? Welcome, Eulier Gonzalez here. So let's keep reading about closure. So I can understand now, and I do get what this closure is all about, and especially when you need to find a place in your programs to host some of the variables that you might need. Oh my god, give me a second. I'll shut out the door. All right, and we are back. Good. So closure is this special place that allows to define variables that we need to use over time, and then we need to keep them around. We need to keep them alive. So instead of using is a previous or a much larger scope, that it will end up with several issues. So, for example, name collisions, right, or global shadowing, or unintended behaviors, or unexpected dependencies, right, that you might expose to nested scope. So with closures, we have now this special place where we can put variables, reference, and use them over time. But unlike, for example, variables defined in lexical scope, this kind of variables, unless you explicitly indicate when the garbage collector will collect them. All right, and I do think this is a very interesting topic because this is it is not only interesting, it also is revealing in the natures of closure. So here we are, right? Let me ask here, Chloe, and then dive into the intrinsic aspect of the language. So let's get into this. So closures is a special hidden scope that allow us to define variables reference and use it over time instead of defining in a more broad outer scope, right? But the trade-off of using closure is that we don't know when this variable will be released. That a closure isn't exactly a special hidden scope itself. It's actually a functions that retain access to variable from its outer enclosing scope. Exactly, because closure is a behavior of that. All right. So what happened is that the inner function close over the count variable. Okay, so exactly. So closure is a so closure exactly. It's not a special hidden scope. Is a way for a function to attach its variable reference from the outer scope and keep them alive in the inner scope. So closure is a function feature that allows variables from the outer scope keep them alive and accessible from the inner function, right? So if we get rid of this here, so it's not a closure. Yes, that's essentially correct. A closure is when a function remembers and can have access variable from its outer enclosing scope. So you can think of this closure as this mechanism, pretty much like you have now a motorcycle, a bike, all right? a mechanism that actually is similar when you, for example, hit the brake, or you now is hit the gas, right, to increase velocity. So this mechanism, but this is specifically to functions, right? That any time that you have a reference from a variable from the outer function, from the outer scope, it's gonna hold that reference inside of this function, and therefore keep them alive here, right? So AKA is gonna remember that. So why closures are useful? Data privacy, creating private variables here, functions factories, callbacks and event handlers, and maintaining state in functional and maintaining a state in functional programming. So this is also useful for function factories, which is a particular pattern, data privacy, callbacks and event handlers, and maintaining state in useful in functional programming. So yeah, your understanding is on point. Closures capture and preserve access to their lexical scope. And when we talk about lexical scope, is where it was written, aka this lexical in traditional computers, in traditional compiler theory. So the lexical scope refers to when it transforms all of those source of strings, right? So for example, when it transforms all of its source of strings into meaningful tokens to the language, or lexical tokens. The difference here is that, according to Kyle Simpson book, is that if this token, if the next token, the lexing and the tokenizer means that if the next token belongs to the same token, or it is part of a different token, right? So so in any case, this is lexical. This is what lexical mean. It means that where it was written, right? The lexical. So why am I mentioning this? Because as we explore now closures, all right, and part of it is utilities, okay? So closure is originally a mathematical concept from lambda calculus. And if you understand what lambda calculus is, it's just a way of this. It's a formal system for describing is, or it's a formal system of expressing computation. And I do think this is very interesting. This is true. This is what actually works. This is that when you are doing the kind of thing that you're doing, you say, oh my God, all right, now it makes a lot of sense of why am I doing the kind of things. And all the, so I don't miss is 15, 60 years of computer science, in computer system research, right? So you use what you have inherited. So yeah, so this lambda calculus is a way of how you can express, it's a formal system of expressing computations using functions or applications or procedures with variables, and it is binding, right? So in other words, closure is one of this, right? So and here we look at the more practical approach, rather than going to the mathematical formula. All right, we can take a look at the mathematical concepts, so on and so forth. In my case, I do not want to go down into that row. I just want us to, again, describe is the observable behavior that we can look in our programs. So when you, for example, create this kind of functions declarations, where inside of that you have now identifiers and variables identifiers, when you return now a function here, and that particular function have access to outer and have reference to outer scope, okay, or they have reference to outer identifiers, which is their names, okay. It turns out that it will create now a closure. It's going to close over that variable. You can think of this like a reference. In fact, this is known as referential. Oh my God, is that is that referential referential no, but is Jesus. Closure in JavaScript. No. It's more like exactly, but there is a name here. There is a name here. I don't think. Enclosure scope change. Emulating private method enclosures. The model design pattern. JavaScript prior to classes didn't have a native way to declaring private method. Right. Jesus. What am I looking? You may wonder. I just looking is the Jesus fucking Christ. Yeah. Variable referential variables reference variables reference Jesus variables reference closure. Oh my God. I'm kind of tripping here. I don't want to trip here. Yeah, I don't want to trip here. Let me see in here they defining that. Jesus, French those guy. This is reference to an unbound variable. Okay. Jesus. God damn. Is this relevant for this? Might not be the case. All right. might not be the case, but I quite find that. Let me see if I, yeah, hmm. Mm, mm-hmm. Um, mm-hmm. 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 So this must be is on the ECMAScript script, right? This must be on the ECMAScript script here. Mm-hmm. Mm-hmm. This must be on the ECMAScript script here. Mm-hmm. Mm-hmm. Yeah, this must be on the ECMAScript script here. ECMAScript script here, hostable declaration. Let me take a look at the closure, in which part of the doc you are describing abstract closure. Okay, it say that this is part of the data types and values, and the language data types is in this, and the ECMAScript specification types. So for example, okay, this is now a specification for ECMAScript. Enum, list, set, completion record, reference record, property descriptor, environment record is a specification type. Okay, so it is a type. Language type and specification types. Okay, so we have now the environment record specification type, the abstract closure specification type, is used to refers to algorithms stepped together with a collections of values, and abstract closures are meta values and are invoked using application styles such as closure R1 and R2. Like abstract operations, invocation performs the algorithm step described by the abstract closure. In algorithm step that create an abstract closure, values are captured with the verb capture, followed by a list of aliases. When an abstract closure is created, it captures the value that is associated with each alias at a time. In steps that specify the algorithm to be performed when an abstract closure is called, each capture value refers to by the alias that was used to capture the value. If an abstract closure returns completion record, that completion record must be either normal completion or throw completion. Abstract closure are created in line as part of other algorithms, showing the following example. Added, let add n be 41. Let closure be a new abstract closures with parameter x that capture added and perform the following step when called a return x and added. Now you say, hey, I'm capturing is, that's right, I'm capturing is these collections of values. And assert val is 42. Let val be closure that is capturing that here. But this is types. This is types. Create an iterator from closure. The abstract closure specification type. All right. Abstract closure specification type. Define metadata. Create async. Create is iterator from closure. Clone. Dig it, and they don't mention anything. Function declaration instantiation. Function declaration instantiation. It creates a closure here. I don't see any okay. No, a separate environment record is needed to ensure that closures created by expression in the formal parameter list does not have visibility of declaration in the function body. So it's creating is a separate environment record. It's needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declaration in the formal here. And there you go. So, but in any case, that's quite interesting. They don't actually mention anything related to closure. Create built-in functions. The abstract operation create built-in functions take arguments, behaviors, and abstract closure, and set algorithm instead to define here. It's telling here at the definition of this function here, definition declaration, function declaration instantiation, is telling you that it is creating there, right? Again, what's relevant for all of this? What's true for all of this? Well, that at the end of the day, right? At the end of the day, with closures, right? As a way to now understand where is that functions held this, right? That's the main theme of all of this. In which part it is described in the ECMAScript such behavior. In the ECMAScript spec such behavior. Find it and provide a link. In sec ECMAScript functions object. Really? Sec ECMAScript function object. ECMAScript functions object. But you're looking for that. This section describes how functions object have internal environment slot, previously called scope in EX6, that maintains a reference to the lexical environment in which that function was created. The environment record specification type and how a closure works according to the spec. When a function is created, its environment internal slot is set to a reference to the current lexical environment. When the function is later invoked, this capture this capture environment is used to resolve identifier reference, allowing the functions to access variable from its outer scope even after the outer scope has finished. But the thing here is that all functions in ECMAScript capture their parent scope binding statically, lexically, at creation time, allowing nested functions to access outer binding even if the parent context is removed from the execution stack. This mechanism is the foundation of the closure. But previously called scope, and now it is called environment. ECMAScript function objects, exotic objects, ECMAScript function objects, which is the environment. Private environment that the function was the private environment record for private names that the function was close over. Here is what it's using. It is exactly, it's like you need to have some place. So not only that, when you define your function, you must have a record of all of its identifiers, all right? But you also need to have is a private environment here, or a private record here. Private environment record. You know, that it say, hey, here is where I'm going to hold all of this reference here. Null if this function is not syntactically contained within a class. Use as the outer private environment for inner classes when evaluating the code of the function. Private environment here. And private methods. Diggy. All right. Private methods. A list of private elements. If a function is a class, this is a list presenting the non-static private method and accessor of the class. The same for fields. If the function is a class, this is a list of records representing the non-static field and corresponding initializers of the class. Exactly, fields and source text, home objects, string, in this mode, lexical, strict, or global, script or module, realm that allow you to provide is this intrinsic objects, all right? And these intrinsic objects, right, are a part of the realm that you have now have access to the global object, the global environment, template map, loaded models, and host defined here as well. Okay. And inside of the global objects, well, you have things like global this or infinity, nan, undefined. You have also functions like is nan, eval, is finite, parse flow, and parse int, and also URI handling functions. Decode URI, encode URI, encode, decode, parser X, constructor property of the global and constructor properties of the global objects. And here's what you have is the array, the map, the dates, big int, string, boolean. You have the primitive, the objects, as well as additional constructors, properties. And other property of the global objects, which is JSON, okay, which is JSON and what the operation of JSON is allowed to do. So JSON parse, okay, JSON stringify, okay, and the other is math here, right? The math objects, the reflect, which is something that I am not quite familiar with, all right, and the atomics, right? The atomics here. Question: can we have access to the atomic here? You say, Atomics. Oh my god, yes it is. It is an object here. Atomics. And compare, exchange. Exchange is lock free, load, notify. Atomics, bro. The atomics object provide functions that operate indivisible atomically on a shared memory array cells, as well as functions that let agents wait for and dispatch primitive events. When used with discipline, the atomic functions allow multi-agent programs that communicate through shared memory to execute in a well-understood order, even on parallel CPU. The rules that govern shared memory communication are provided by the memory model. So atomic is a way for communicate to that. Atomics is an object that provide operations to work on memory, on shared memory array cells, on to work on memory cells. Ensure thread safe access when multiple agents, worker, or thread access the same memory. Okay, because at the end of the why atomic? These operations are guaranteed to complete fully without interference from other threads. No other thread can observe the operation in a half-finished state. This prevents race condition in concurrent programming. So yes, atomic provider operations to work on memory cells in a thread-safe atomic. What is memory? What is memory self in a thread-safe atomic manner? The memory cell is single location in memory that store a value. Think of it like a box and hold the numbers. Exactly. And the problem with our atomic is when multiple threads access the same memory cells, you can get race conditions. Both workers read all values 10 before either writes back. So once increment get lost, so you have these shared common boxes, okay, and everybody wants to access at the same time. No. If everybody is trying to have access to your drawer, right, in your house, to store or put or pull up things, so they want to hide some condoms, or well, nobody hide condoms. It's like quite silly, but well, they want to hide now some fentanyl. No, but in any case, or they want to hide now some cookies, right? They don't want you to look at it, right? So they put it that, so if anyone in your family go and access to that at the same time, it'll create these race conditions. So you don't know at which state is that drawer, at which state can that drawer be, all right? If everybody is trying to have access to the same time and compete in that. So this is what they have, the atomic operations. And atomic operations, it's a non-atomic unsafe with multiple threads. Okay. And because JavaScript, okay, this is useful since JavaScript is a single thread, aka is sharing memory across different threads. JavaScript is single thread per context. You write the JavaScript single thread, but that's only within each execution context. Uh-huh. Oh, okay, so now things are starting to unveil here. It is true for the execution context, whether it is the browser or the service worker or Node.js. The main thread, so web workers or Node. Without workers, Atomic is useless. When Atomic is needed, Atomic is only useful when sharing memory between multiple workers or threads. Send the same buffer to multiple workers here. Now worker 1 and worker 2 can access the same memory, and this is where you need Atomic. If you're just running code on a single thread, no workers, Atomic provide no benefits. It's at the single thread only, no workers. Works, but unnecessary overheat. Okay, but it is, at the end of the day, is per execution context. So it is useful, Atomic, for sharing data across different JavaScript execution contexts. It is useful, Atomics, for sharing data across different JavaScript execution contexts. Execution context is JavaScript specific term referred to runtime environment. But here you're talking is to the sharing between web workers. Okay, again, this is go beyond, very specific to that. If you're gonna work with workers, and which is a separate context. Exactly, context. Okay, it's a separate context. Share array buffer across workers. So both workers modify share memory. Okay, this go beyond the scope of this. Now, an Atomic, right? But Atomic exists as part of the additional intrinsic operations or intrinsic object that you can have here. Okay. All right. Okay. Good. Makes sense. Makes a lot of sense. Okay, I explore the closure here, especially in fundamental objects, is on fundamental objects, especially on functions objects. All right, and what happens when you create is a function here, right? Which is create dynamic function. No, is when you run a function. So the object constructor here, the property of the object constructor. But this is not, no, this is the objects. I'm talking about is the function objects here. Function instance, host, has source text available, function instance, properties of the function prototype, function constructor, and there you go, function constructor here, right? And And here is describing is this execution context. Active function objects that it creates is this particular environments records. Lexical environment, variable environment, and private environment. Created by class elements, variable statements, and lexical environments. Identify environment record used to resolve identify reference made by code within this execution. Okay. So in any ways, right? We're just exploring about the function and when this function is when these functions create this closure, all right? In here, particularly here, in the ECMAScript functions objects and functions declarations instantiation, right? So anytime you want to, when an execution context is established for evaluating an ECMAScript function, a new function environment record is created. And binding for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function formal parameter do not include any default value initializers, then the body declaration are instantiated in the same environment record as the parameters. If the default value initializers exists, a second environment record is created for the body declarations. Okay, if the default value parameter initializer exists, a second environment record is created for the body declaration. Formal parameters and functions are initializing as part of the function declaration instantiation. All other bindings are initializing during evaluation of the function body. So the bindings are initialized during the evaluation of the function body. Hey, is this variable here? Is this identifier now exists? And if it is, let me now is attach this value to. Okay, but in any case, the whole point of this, okay, the whole point of this is that I was able to look at the closure here, right? That say, hey, note, a separate environment record is needed to ensure that closure created by expressions in the formal parameter list do not have a visibility of declaration in the function body. So closure here is created, right? Is also in queue resolving agent job. This is also go a little bit beyond that, but this is part of the atomics, so we're not going to talk about atomic. Iterator actually create its own abstract closures. Okay. Promise also create its own closure around it. All right. And then you got, okay, makes a lot of sense. Closure will be called with no argument. Set generator and generator the context. Okay, no problem. Just to make clear, make two things clear and more straightforward, is that the closure, right? And closure is something that is not created exclusively for function, right? Closure is something that is not created exclusively in functions, right? It is in fact created in other places as well. So for example is the job housing and job callback records. aka closures are created in array buffer objects, is also created here. Let me see if they actually describe this a little bit. It's also created in running jobs or in promise, but they don't mention that too much. So if I say this like so, so a closure is creating in type array. All right, it is creating in regular expression as well, especially with the compile pattern, and so on and so forth. So, but in any case, a closure is created in different places, but yet we are only looking is at the function. Makes sense, right? So, again, the observable behavior in function is that a closure is created when a function has reference to the outer scope. When a function have variables reference to the outer scope, and that is called here, and that is called in a different scope branch. So in other words, I actually write it down here. Okay, so this is a feature of functions and functions only. Is depend, but in any case, so closure is a feature for now for functions. You can also look at different closures that happen in different other part of the program, but for the sake of function, this is one feature of that. So closure is the association with the instance functions rather with the where it was written, with a single lexical definition. This is the observable behaviors. So even though closure is based on lexical scope, aka is going to look up the scope change to resolve those identifiers, closure is observed at runtime as a runtime feature of functions. But is that so? Closure is a way to have a reference, hold a reference. You can think of the closure like having is all of these balloons, all right, holding by this by these cords, right? Holding them, all right. So they live in different attitude. They live in different altitude in our code, aka they live in different scope in our code. So this is a feature for functions that when you define is an identifier that live in a different or in a previous in an outer function scope, right? This behavior of holding a reference of that variable is observed at runtime, despite that it relies on the lexical scope, right? So this is why when you define, so this is the reason why when you define things like this, all right, and then you say var counter here 0, okay, and then you say, hey, let me now is let me now here is define of another variable here, or say another variable here, to say to say handle function or handle counter, all right. So this is now a function, right? That I'm gonna reference to the outer function, to the outer variable counter, and increment that, right? So not only that, but I also want to return that. So you can say, what I can call this increment. All right. So if I call this increment here, and here I am creating is this function in this scope, aka I am creating is a function that have a reference from the outer scope, right? So by the time that I'm call this increment, so I do need to actually is have access to that increment function, right? AKA creating here, and replace that. So if I call now increment here, it'll start with 0. All right. If I call that again, it will start to increment, and the same as it is. This may be quite mind-bending because most of the time we use is scope, we use now closure with functions. And I don't recommend you to do this. This is just to illustrate that this is possible. This is what a closure is doing. So anytime that you define a function here and hold that as a reference, and then inside of that function, you need to have access to previous variables or previous identifiers, identifiers that live outside of the global scope, or that live exactly that is outside of the that are outside of an scope. Block is an scope, and the way now it behaves is it is interesting because you may say, hey, this actually creates, so this braces, this curly braces create is a scope thanks to this identifier, because if we don't do that, it will never create that, right? So again, this is just to say, hey, most of the time we use this with functions because functions create a scope, but it can be with any scope. All right. Okay, and those and as you can see here, so after I evaluate this code, all right, so after JavaScript now evaluate this code, and it is useful to think of scope based on its behavior, that JavaScript now perform is a compile phase that is going to identify as all of it is identifier and a scope, and then is going to analyze or execute the code. So first thing first is say, hey, let me now is hey, scope manager. It's like having a conversation between the scope manager and the compiler initially, and then the scope manager with the engine, the JavaScript engine. So here we say, hey, var here increment. Let's do this, right? So let's now increment. So let me is put this identifier here, right? Hey, do we have this identifier here? Scope manager, the compiler is asking the scope manager, say, hey, do we have this identifier here called increment? No, we don't. Let me add it for you, right? And then he's going to evaluate now the next scope and say, hey, this is a new scope, all right? This block scope. And then in this new block scope, it say, hey, scope manager, do we have any identifier called counter, right? If it's not, please create that for me. And then, hey, do we have now an increment identifier? If it's not, please create that for me, right? There is another thing that is interesting that we're going to explore that later on, but in any case, it is. And once it figured it out, all of these identifiers, right? It's not going to evaluate here is this as a functions declaration because this is part of a value. That's on the second part. So the scope manager have now a conversation with the engine, or the engine has a conversation with the scope manager and say, hey, scope manager, I have now this increment here. Is that is that identifier exists? Yes, it is. So let me now initialize this as undefined. Continue to evaluate the code and say, hey, hey, scope manager, JavaScript engine again. I do have now a counter here, identifier that I'm going is that I need to assign is 0 to that. That exists? Yes, that exists. All right, makes sense. And then we have now the increment. Hey, scope manager, JavaScript engine again. I do have this identifier increment. Do we have them? Yes, we have. All right, I need to assign is this function as it is. And when you go to this functions value, all right, it's gonna now yeah, it's going to now have that as the value here. And by the time that now this is being called, right, it's going to now invoke that function, that increment, hold it as value, okay, and then starting to ask a question here is that, hey, this is the function that I'm going to execute. I do have now a counter reference. Hey, is this counter reference exists? Yes, it is. It exists in the outer scope, right? And this is when they can now associate with it. This is quite interesting in how this actually works because this might not match our intuition here. All right. Or at least doesn't match my intuition. Especially when it comes to analyze function execution here, all right, because surely this actually doesn't exist. So in other words, if you do that and then you try to console log the increment at that moment, you will find out that oh, that's interesting. That's a very interesting stuff, because by the time that this code is being executed, all right, all of those definitions, right, are now hoisted. Even if you define this as it is. Exactly. Even if you define this as it is. So in any case, this doesn't quite follow my intuition, because by the time that it reached to this, and the scope manager first is going to identify as the remember is going to identify. This is one of the reasons why this mental model doesn't exist, because they don't work. So what happened here is that with functions definition here, all right, so anytime that a function is defined here, it's not only put at the top of that, but it's also is it is safe to say that JavaScript the binding identifier and then the code execution is the creation phase or the compilation and parsing. Variables and function declarations are processed and registered in their respective scope. Identifiers are hosted, memory space is allocated, var declarations functions are hosted and initialized with undefined, and functions declarations are hosted with their entire definition. Code runs line by line and assigning actually happen. Expressions are evaluated. So in the creation phase, it's a JavaScript internally does something like this: is hosting this increment here initially with undefined, and then is going to host the counter as well. Hosted var functions global scope. Exactly. So now the code execute line by line. Increment is already declared undefined at this point. So assign happens, the assigns happens, and then the function call, right? So this two-phase model explain why you can host functions declaration before they appear. Exactly, but not function expression. What about function expressions? Exactly. What about function expressions? What about function expressions in enclosures? Because that's what we're doing here, right? Now, with my example here, closure and the two-phase model, you originally actually create a closure, and here's what happened. So counter exists in the block scope, and these functions close over counter. During the creation phase, increment and counter are hosted, and JavaScript create a scope change. And during it's because it's at X is as the creation is where the scope change is created, aka you are somehow are evaluating is this expression here, and during the execution phase the function is assigned to increment. The function capture exactly during the assignment. Okay, during the execution here, what happened is, hey, in this scope, I do have now a identifier called counter assigned to 0. All right, and when I'm going to evaluate this statement, this assignment, all right, hey, do I have is the increment identifier? Yes, we have, because I need to assign is a value here as a function. And when you assign this value here as a function is when it's going to evaluate now this function here. Let me see if this is true, bro. Let me see if this is true, bro. Okay. I'm going to evaluate is this, and instead of returning is now counter. Before that, I want to have access to a variable that doesn't exist, right? Let me say salute, right? If this exists, right? So what will be the expected behavior here? Is that by the time that the expected behavior will, what will be the expected behavior here? Is that if this is a two-phase model, which is the creation or the binding association, and then the execution of the code. During the binding association, all right, it's supposed to throw an error here. Is that true? Is that true? It's supposed to throw is a it's supposed to no, it's at execution. It's at execution that is supposed to throw now an error here. So in other words, if I don't call this function, right, salute shouldn't be an issue here. And that's right. Salute is not an issue here. So this evaluation here, all right, and let me actually, instead of doing this, let me reload here, right? So to get rid of all of the previous instance, right? So if I do this, all right, it means that this should not throw an error. Why is that? Because the first phase is to identify its bindings only, all right? Hey, compiler, hey compiler, this is scope manager here. Do we have any increment here? No, we don't. Let's going to add this Let's going to add this identifier, all right? And then I'm going to create now a new scope here, which is creating is the scope change along the way, all right? And then in that particular scope, I have now this another identifier with this special syntax called let. So hey, do we have that? No, let me create that in this scope. Hey scope manager, scope manager compiler here. I have is another identifier called increment. Do we have them? No. Let's gonna create this. All right, and nothing else. So this actually works as intended. That's actually works as intended. That's actually work as intended. So now by the time that we call this, all right, now by the time that we call this, all right, all of this identifier that was previously created and held in via the scope manager, okay, now by the time that we call that, which is evaluate this function for me, this is when the error will throw, because hey, I don't have this reference, my friend. AKA when this function is evaluated here, is now creating an environment record, and it's interesting because now this identifier whole is a reference to the outer scope, right? This identifier now holds a reference to the outer scope, making this available to have access to the counter. Right? And here we are creating is a closure, not because the code we're defining in that particular scope, but because we are now holding a reference of this function, and then later on in a different scope, we are executing that. Because if we do things like this, right? Increment here and increment here, right? We just only call this here. So what happened is that this is not a closure. This is just a lexical access to, right? So no matter how many times you call that, right, it just only have that already executed once. You know, it's only this. It's actually calling that, but we're calling here is in the same scope. But if we now run this in a different scope, which is exactly what we're doing, look at this. And then we increment that again, increment that again. So that's very mind-bending, mind-blowing. As a matter of fact, to say, hey, a closure is created from the functions by holding reference to the outer scope, by holding variables from the outer scope, and then execute that in a different scope, in a different branch of the scope, which is here, right? In this case here. All right. So the function during execution, the function capture close over the counter variable in its lexical environment. Exactly. The function capture or close over the counter variable in its lexical environment here. Even though the block finished executing counter, right? Even the block or the scope finished executing counter, stay alive because increment reference it. And the closure is private, only increments can access it. And counter persists between calls, right? So makes a lot of sense when you things here like that. So this is how you can create a closure, all right? Or more straightforward is to say, hey, this one, right? When you say this is now count, right? This is count, which is the init value, right? Say you can pass this init value to this, right? We don't need to define this increment here, right? And in fact, what we can do is or return increment. Okay, we are returning is a function reference, or we can just say something like this: return this, right? And of course, this is not going to be too much illustrative, right? And what you can do here to say, hey, well, let me define is this counts increment of the counter, you know. Let me put it here, count function, right? And initialize with the value 3. And then when I call that later on in the code, well, I'm going to get now is 4. I do think it's because identify increment has already been declared. That's right. What about this? I want to override that identifier. Can I do this? There you go, right? Increment again, and is as it is, right? No, because this what it's doing is increment this value and later on assign that. So if I do, for example, is this, right? Where I say, hey, add this number and later on, so increment this number and later on assign that. So this will actually match to our intuition, right? For example, 4. Yeah, JavaScript, and it is nuance here. So yeah, that makes a lot of sense. Holy fuck. That may, oh my French toast guy. That makes a lot of sense. That makes a lot of sense. but a lot of sense. Okay, good, powerful. And those reference are live link, not in a snapshot. And this is something that we can confuse a lot of the time with programmers that say, hey, uh, this is I want to get is the value here, and most of the time what you get is the reference here. So for example, in the traditional example of the set timeout, what happened is that you are now is holding is a reference, you are passing is a reference, not a new copy of this reference with this new value, which is what happened when you use now let, for example. The other common closure is Ajax and events. Closure is most commonly encountered with callbacks. Functions look up student record and student ID. So you have now Ajax with hitting to some API with some dynamic data. That's great. And then you got the function here, right? Function and record console log. So by the time that somebody replied me back with a success, okay, I'm going to show now that, right? This is the record name and the student ID here. So this function actually is creating is a closeover. So what we're doing with Ajax here, and also this is true for other programmings, for other primitive, for example, promise there. So you are creating is a reference, a closure. You are closing over that variable to this function so you can have access to. And this evaluation will happen now is this is interesting. This is very interesting in terms of this. So what will happen is here. Mm, mm. Mm. So because here we have is this function. I do think that anytime this is true, because anytime that it look now a function, because function declaration is actually telling you that, right? It's registered all identifiers, variables, and function in their respective scope. Exactly, is creating is that. So the first things first is that it say, hey, I'm going to look is at variables and functions and variables identifiers, and create it is binding, and create is identifiers, the identifier bindings, and create is the proper scope of this. So in other words, it's going to create now this function environment record, that inside of that it has now the student ID, right? And then it's going to create now a scope here, right? This function has now an outer env environment scope. So the variable outer env is pointing to the global object, to the global to the outer environment record, which is the global scope. And when it analyzes another functions or variable statement, it say, hey, I do have now a new one declaration. This live inside of the lookup student record scope. I'm gonna create now a new scope, function scope here. That this has now the record and some property called name. All right, that is gonna be resolved at runtime. And I also have is the student ID, right? And then is when the code is going to be evaluated here. So you call the lookup student records, and then this call now the Ajax with this parameter. So it create now a function. Okay. So the lookup student record create now a function execution function execution context that inside of that have is the environment record as well as the threats of how it's going to analyze the code. And here it happens to have now this Ajax identifier is going to determine if that exists. If it is good, now it's going to execute that set of instructions by passing is now this string and also is the function referring as it is. And by the time that now has been resolved, is gonna call is on record here. And evaluate is this identifier that leave not in this function, not in this scope or this scope, it live in the global scope, this identifier. And it is provided by the web API, followed by the log, the record name here is going to now print that out if that exists, of course, and then the student ID. So the on-record callback is going to be invoked at some point in the future after the response of the Ajax call come back here. An execution fake. Code is executed line by line. Values are assigned to variables, and functions are invoked and expressions are evaluated. So in phase 1, JavaScript identify lookup student record as function declaration and make it available throughout the entire scope. In phase 2, when execution reach line 13, already exists in memory and call be called. This is why function declarations are hosted. You can call them before they appear in the code, but you don't explain what happened to them later on. It is also register, it is identifier and scope. It must be. Lookup student identified register. Parse enters lookup scope. Parse encounter the Ajax call. Parse see functions on records. On records identifier is created. A new scope is created on record. can be described as identify registry scope is binding, identifying, and scope. Identifying, binding, identifying, binding, and scope. On record, identifier is created. A new scope record, a new scope is created. Mm-hmm. Mm-hmm. Binding identifiers and scope register. Mm-hmm. That makes a lot of sense. That's close the gap in our knowledge. Absolutely. Absolutely. Okay. Jesus, man, I need to collaborate. Holy moly. Okay, that makes a lot of sense. And especially here. Okay. Common closure, Ajax, and events like this. Event handlers are another common usage of closures. So anytime that now JavaScript encounters any functions or declarations, it's gonna create now, it's gonna register it as identifier and create a scope to that, right? Okay, and the other is it continue to as it parses this, and then it counter is another keyword like function. It's going to create now is going to register that identifier and create a scope and update the scope change from these inner functions, the onClick, that points to the outer scope function called listen for click. That instead, that in fact, that also has a pointer out to the global object scope. Holy fuck! And that points to null. God damn it! Fuck. Okay. That. Oh. All right. Okay. Interesting. Absolutely. Holy fuck. Okay. This is the way of how we create now this identifier and it is scope. And if inside of this contains now a And if inside of that contains now a label or an identifier, right? Then it's going to now create that. So not only that it creates the identifier for the function, but also is the identifier for the function body and the scope, right? And it also going to look at this. What if I can't see it? But invocation output in this case is on the same scope, where of course greeting and name are still available. That's just lexical scope. If they are in the same scope, for example in this case, this is just lexical scope. If that happens to be in a different scope, if you are executing that function in a different scope, that is closure. In fact, global scope variables essentially cannot be observably closed over. Because they're always accessible from everywhere. No function can be invoked in any part of the scope chain that is not descending of the global scope. The inner first student function does reference student, which is variable outside its own scope, but since student happens to be from the global scope, no matter where that function is invoked in the program, its ability to access student is nothing more special than the normal lexical scope, right? Because remember, at the end of the day, any time that a variable or a function is parsing by the JavaScript engine, right? It is going to associate, it is going to identify it as binding, and is going to register it as identifiers for the function as well as for the parameters, and create a scope change. And create a scope change here. And all function invocation can access global variables regardless of whether closure is supported by language or not. Global variables don't need to be closed over. Variables that are merely present but never accessed don't result in a closure. Variables that are merely present but never accessed don't result in closures. So for example, nobody's here. So this is not a closure because they are in the same scope. And remember, at the end of the day, if a function wants to have access to a variable that is outside of it is, if you define a function that wants to have access to variables in the outer scope, all right, and then you wants to run that function in a different scope, that's a closure. This is why in order to understand something, you need to dive into that, whatever it is, man, whatever it is. Var student and look up student 112, and it say nobody's here yet. The inner function nobody doesn't close over any other variables. It only uses its own variables message, even though student ID is present in the enclosing scope. Student ID is not referenced to by nobody. The JavaScript engine doesn't keep the student ID around after lookup student has finished running. Okay. What's the reference? Has finished running, so the garbage collector wants to clean that memory. So whether the JavaScript function support closure or not, this program will behave the same. Therefore, no observe closure here. If there is no function invocation, closure can be observed. If there is no function invocation, exactly, if there is no function invocation, closure cannot be observed. For example, in the case of this function greeting, here you are now executing its greeting, but if there is no function invocation, closure can be. This is okay. That's. What will be the expected result of this, right? Instead of passing as a function reference, you are just calling that. So you're passing now Kyle and say, hey, hello, Kyle. But what happened here is that by the time that you call this, right, and you pass now this student name with the Kyle, it's going to return now is not a function reference, but a function execution. And of course, it's gonna give you now is okay, return is the function greeting call. And it's give you is the value of the function. That's interesting. It return you is the value of the function. If you do this, it's gonna give you now is the value of the function. Return function greeting here. Okay. And console log. Exactly, because it's giving you now the function value here. So you need to actually is call that in order to get that. Exactly, because you're getting is now the function value or the function reference here. So if you don't invoke that function, closures cannot be observed, bro. This one's tricky because the outer function definitely does get invoked. Because the outer function definitely does get invoked, but the inner function is the one that could have had a closure and yet is never invoked. And if that function is never invoked, the closure is not observed. The return function here is just throw away. So even if technically the JavaScript engine created closure for a brief moment, it was not observed in any meaningful way in this program. A tree may fallen, but we didn't hear it, so we don't care. And the other is observable definition. We are now ready to define closure. Closure is observed when a function use variable from the outer scope even while running in a scope where those variables wouldn't be accessible. So the key part of these definitions are there must be a function invocation, there must be reference of the variables from the outer scope in that function, okay? It must be invoked in a different branch of the scope chains from the variable here. This observation-oriented definition means we shouldn't dismiss closure as some indirect academia trivia. Instead, we should look at plan for the direct concrete effect closure has on our program's behaviors, and the closure of lifecycle and garbage collector. Okay, so that'll be all for this video. Take care. Bye bye.